Broadcasting live from SETI Alpha 6 in the Andromeda Galaxy, this is Mr. C.
Happy Tuesday, and a happy Tuesday it is. Look at me. Sweatshirt. Why would that be, Mr. C? And the AC is turned off, the windows are open, and that is very cool air that's coming in. Thank you, God. Finally, as my daughter Laura says, a really true fall day like you might have up in the Midwest, like in South Dakota or Michigan or Minnesota. So today's high is only going to be barely above 60. Folks, that is 10, 20, 30, 40, probably 50 degrees Fahrenheit cooler than temperatures that we had for highs just 6 weeks ago. So amazing. And down in the 40s tonight. So just something to thank God for. SSR, big time SSR. Hey, test makeups, if you haven't taken last Friday's test, get it done by Thursday. Make arrangements with Mr. Gilbert. That would be great. So on your white sheet, get ready to write down a few things. You've got out your textbook, and you've got out LS 10, 11, and 12 in front of you. And we will deal with that some in just a little bit. Hey, the verse you're going to write on Friday on your test is Psalm. Can I find it? Where is it? There it is, right there. I'm pointing to it. Psalm 19:1. The heavens declare the glory of God. See that? The skies proclaim the works of his hands. So as we study all these astronomical objects, they are shouting, God made me, God made me, God made me. Why? Because of their precise orbital speeds, and in the case of the Earth, all of Earth's just rights, just screaming, God had to design me, God had to make me. Our sun the same way, just its size, what it's made of, hydrogen and helium, the fusion that occurs on it, the amount of heat and light that's produced, just right for planet Earth, on and on and on. Okay, now in your textbooks, you had to write down on 85 across the top where each of the planets are located in astronomical units. So you should have had that, and then on 87 as well. Now, here's the story. I've got so much to cover today, I don't want to spend time on that right now. So make sure you get it done. And when I tackle it tomorrow, when we go over it tomorrow, pardon me, make sure you've got that homework done. Okay, RenWeb is up, and you have your homework on RenWeb, and it's to review all of this, to go over it, all of this information. Psalm 19, my very educated mother just served us 9 pizza crusts to identify the planets from the sun out, my Mercury, which we'll talk about in a little bit, and it's so interesting, the planet Mercury. Very Venus, another incredibly interesting inner planet. Educated Earth, of course, mother for Mars, interesting inner planet, and then just Jupiter serves Saturn, us Uranus, 9, Neptune, and pizza for Pluto. I'm still going with Pluto. I know it's a dwarf planet. I know there are like 4 other dwarf planets. Ceres, Hamane, and the other 2, which we'll cover next week. I'm sure we won't get to it this week. Okay, so that'll be at MyVary. That'll be on the test. Okay, what the solar system is made up of. What is the solar system? Sol, sun. So of course the sun, the inner planets, the outer planets, the asteroid belt, and other asteroids besides the ones in the asteroid belt, and then comets. So and all of those objects make up the solar system. So all of them. And then I wanted to tell you what the word planes means, from which the word planet is derived or comes from. Planes, it's a Greek word, and it means wanderer. So the Greeks, thousands of years ago, looked up at the night sky and they saw these objects wandering across the night sky. And they named them, the general word for them, planes. And we use the word planet now from the word planes. So, anywho, see if I missed anything up there on the top section. Oh yeah, I was going to recommend that you have in your journal a planet section where you put everything planet-wise on those pages. So I recommend it now, giving you a little time to do that. Planets. And in there you're going to put anything about the planets. So solar system probably would be a good spot to go there. Solar system. MyVary. The whole enchilada for MyVary. My very educated mother just served us 9 pizzas. Want to stick it in your head? Sorry about that. Some of you go, yeah, Mr. C, you're sticking it in my head and it makes me want to toss my cookies. Sorry about that. So I always have allergies these days, and it makes my singing voice, let's say, somewhat below what it normally could be. Mr. C, I don't think you can really sing at all. Well, that's a truism right now. But I will tell you this. I used to be in a singing group like 50 years ago. And I could kind of stay on key. So struggle a bit more these days. MyVary. So you've got it in your journal. You've got solar system in there. Now I want to teach you about the inner planets and then the outer planets. Just what do the inner planets have in common? And right now you're seeing a video on the solar system. So you're seeing the sun and the inner planets and then the outer planets. So you're seeing all of that right now. Writing myself a little note so I can have that photo put in the right place in the video. My son-in-law does all that prep, and I'm really thankful for all the help he gives me. So you're looking at the 4 inner planets. That would be Mercury, Venus, Earth, and Mars, compared to the outer planets, compared to Jupiter, Saturn, Uranus, and Neptune. You can just look at them and go, what's the difference? What do the inner planets have in common with the outers? So you're looking at them, and what do you think? So you look at them and you go, and I'm going to give you the characteristics of the inner planets. They're small compared to the outer planets. So you've written inner planets down in your journal, and now their characteristics. They're small. They're rocky or solid. We call them the terrestrial planets. I'm not going to ask you that. But when you hear terrestrial, go, oh yeah, the inner planets. They're rocky. They're solid. The outer planets are gaseous, not solid. Gases. Okay? The inner planets have few just few or no moons. So the inner planets, small or rocky, few or no moons. The outer planets, just the opposite. The inner planets are slow rotators. Slow rotators compared to the outer planets. The inner planets are fast revolvers around the sun compared to the outer planets. So 4 major characteristics I would like you to remember about the inner planets, what they have in common. Small, rocky or solid, few or no moons. I guess actually this is 5 characteristics. Slow rotators and fast revolvers, revolving around the sun. So there are the inner planets. Now I'd like you to take a minute with Mr. Gilbert or 2, and he can answer any questions for you. So a little break, little stop, Mr. Gilbert. Okay, I'm back, and we've just done the inners, the inner planets, now the outers in your journal. I'd skip a line. I'd always try to skip kind of space in your journal what you put, so it's easier then to, if it's not jumbled up in your journal or your notes, it won't get as jumbled up in your mind or your memory. So the outer planets now, what are they like? Kind of just the opposite of the inners. The outer planets are huge compared to the inners. So they're massive. So number 1, the outer planets are huge. Number 2, what are they made of? They're not solid. What are they made of? They're made of this. Not exactly these kinds of gases, but they're made of gases. And very thick gases, but they're gaseous. These are sometimes called the gas giants. Jupiter, Saturn, Uranus, and Neptune. The gas giants. Because they're huge, the giant idea, and they're made of gas. So there's 2 characteristics of the outers. They have lots of moons. Not a few, but lots of moons. I didn't really tell you, and I should have probably camped on it a little bit more, a little more detail. The inner planets, Mercury, no moons. Venus, no moons. Earth, 1 moon. Mars, 2 moons. I told you, few or no moons. Now the outer planets, different story. Lots of moons. Jupiter and Saturn have 60 plus. And then Uranus and Neptune have in the teens. You don't have to know, but just in the teens. The outer planets, lots of moons. Now the outer planets does not include, of course, the dwarf planet Pluto, which actually has 4 or 5 moons. I think 5. So, but anyway, for another time. So there you have it, the characteristics of the outer planets. Now, I want to go over really quick. You have been given LS 9 and 10. And 11 and 12, and 13 and 14 maybe, okay? And you could put them all together. But I'm not going to ask you any questions about LS9 except the only thing I'm going to ask you about LS9. I'm going to ask you, so turn to LS9 really quick and circle the 2 things about space that I should have asked you on the last test. I don't think I asked you about it. Number 1, space is basically empty. There's no matter, hardly any matter in space, in between the planets and beyond the planets. It's a vacuum, no matter. And then there's no gravity to speak of in space. It's called microgravity. So you wouldn't weigh anything if you were on the ISS. And there wouldn't be any gas outside the ISS. None to speak of. Okay, those two things from LS9. You see I circled them there? So from LS9, two things about space I will ask you. And I'm making myself a note. So there's 2 points that can be on there. So I'm going to write those two things down, microgravity. And you should be highlighting them, right? Microgravity and vacuum. Okay, I'll ask you that. Then from LS10, I'm going to ask you these two things that I already went over, but I'm just reminding you. Geocentric in the top box. Can I do that? I got to line it up just right. Geocentric, the Earth was supposed to be the center of the solar system, turned out not to be right. And then heliocentric, the sun's the center. And a number of guys, including Johannes Kepler and Tycho Brahe and especially Galileo, all got evidence that the sun's the center. So a guy named Copernicus too. The major guy I guess I'm going to ask you to connect with the heliocentric idea is Galileo. So I want you to make sure that you connect Galileo with the heliocentric idea, the sun-centered idea. Because he sealed the deal, didn't he? And it cost him. But he sealed the deal with his telescope and his data. His data on Jupiter and Jupiter's moons. The moons go around Jupiter. They don't go around Earth. And then Venus goes through phases as if it actually orbits the sun, which it does. So anyway, way to go, Galileo. All of that from LS10. And then the other thing, the only other thing in LS10, over on the right side, do you see where I circled ellipse? Can you see that? Ellipse over here. Over on this side. Ellipse. And that is that the planet's orbits are flattened circles, ellipses, elliptical. So when I ask you on Friday, hey, what shape do the planets have? They're not circular. No, not circular. They are ellipse, 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 elliptical. Tell your neighbor what the name is of the shape of the orbits of the planets. Just say it out loud to a neighbor. Ellipse. Okay, that takes care of LS10. Now LS11, from LS11. So what makes up the solar system? Up at the top box, all the things that make up the solar system, the planets, their moons, and a bunch of other smaller objects, including comets and including asteroids. And I think they are included in there if you look around a little bit. Yeah, there they are. Asteroids and comets at the bottom of the top box. Cross off the bottom box. It's the evolution idea, and it doesn't really make sense. And it doesn't match Genesis 1, where God spoke things into existence. There's not good evidence that the universe is 4.6 billion years old. There's actually a lot of evidence it's quite young, only thousands of years old. Later. We'll get to all of that later. So that's LS11. So you've circled planet. Okay, you've got dwarf planet, So you're looking, my bad, I should have had you circle those things, okay? So the sun, the planets, their moons, you're highlighting or circling those. And then I'd like you to know an AU, or astronomical object, which is the average distance from the sun to the earth. That's an astronomical unit. It's a measuring stick to the stars, or at least to the planets. It's a measuring stick, or a way to measure. So we measure the distance from the sun to the planets in AUs, or astronomical units. And then LS12, so you've turned to LS12, and this is the inner and outer planets, which I have already gone over. Okay? So anyway, we will thoroughly go over LS12 perhaps tomorrow. You know, tomorrow's a half day, so I'm going to really have to hurry with the 28 minutes or so that we get, and I only get about 23 or 4 minutes so for my video. Okay, so in your journal, the planet Mercury, here are the details on the planet Mercury. I'm going to have to really hurry. Mercury's small. It's the smallest planet. It used to be the second smallest planet after Pluto, but now we call it the smallest. It's only got 1/2 the diameter of the Earth. 1/2 the diameter. It's heavily cratered. Heavily cratered. You're seeing a photo of it right now. You're seeing a photo of it. And what does it remind you of? When you see Mercury, you go, well, isn't that the moon? No, 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 no. It's Mercury. It reminds you of the moon, yeah. But it's Mercury. Not exactly like the moon, but heavily cratered, and it's got volcanism too. It's got some volcanic craters. So its temperatures, an 1100 degree temperature swing. Wow. From 850 Fahrenheit on the sunny side to -250 on the dark side. An 1100 degree temperature swing. Wow. From day to darkness or day to night. Plus 850, -250. Do you want us to put that down in our journal? Yeah. Plus 850 Fahrenheit, -250 Fahrenheit. It's a real slow rotator. Slow rotator. Like the inner planets. 59-day rotation. Wow. That means it faces the sun for many days and it turns away many days. Is that one of the reasons it's so hot and so cold? Yes. Because it heats up for a long time and then it cools off an awful lot. It's got no atmosphere to speak of. It's got an 88-day revolution. That's fast. A fast revolver, slow rotator, fast revolver. We think it's still cooling, and I would submit to you because it's pretty young. So it's still cooling down like the Earth. It's got an inner core that's hot. And the inner core of Mercury, as it cools, it shrinks. It's actually shrinking. Shrinking. Okay, getting a little bit smaller. And then if you weighed 100 pounds on Earth, you'd weigh 38 pounds on Mercury. So I don't think I missed anything. The reason for its heavily cratered surface and it's really hot, really cold is because of the slow rotation, and it's got no atmosphere. So it's got no shield to block, no shield, no atmosphere to block meteors coming in like Earth has. And most of the meteors that come in to Earth burn up in the atmosphere. Not so Mercury. They come in and just pound the planet. They pound it. So anyway, How we doing time-wise? Because Mr. Gilbert needs to have a little bit of time. But he does have enough time. I've got a little video for you that's very cool that goes over, that reviews Mercury's major characteristics. So I'm going to have him show this video, and then if there's any time left over, he is going to show you the ISS video, which we've got to keep working through. So a video on Mercury, and then perhaps a little bit of the ISS video, and then some time to work on your homework, which is review everything so far about the planets. And you've got a lot. So from the lesson summaries and now in your journal. Okay, well, enjoy the video on Mercury. I think you'll like it. So, and it's Mercury 101, and then Mr. Gilbert will answer any questions, anything you missed, and then perhaps watch the ISS video to run out the period. So I will see you on Wednesday, which is a half day. Adios.